Welcome back. Today we're going to be taking a look at the distributive property of real numbers. So let's start out with what the distributive property is in general. And it says for real numbers a, b, and c, a times b plus c, and remember from the order of operations, b plus c is done first, and then we multiply by a, is equal to a times b plus a times c. So you've probably seen this before. I really like the example used in Lumen, and that is if I want 3 tacos and 1 drink, and I want 2 orders of that, then intuitively, right, if I say I want 2 orders of 3 tacos and 1 drink, you know that we're going to need 6 tacos and 2 drinks. And the way we do that here, you can see that A is 2, so we have 2 times B is 3 tacos plus 2 times C is going to be 1 drink. And simplifying here, we get 6 tacos and 2 drinks. So that's the distributive property. There's a few different ways you may see this. You may see it as, let's say, B plus C times A, where A is on the right instead of on the left, or the grouping comes first. And remember from the commutative property, we can switch these two things around. We can switch the order. And you can see we're back to the same thing. Let's say we have a negative in there, so A times B minus C. Well, remember that negative C is just B plus negative C. And so we can distribute plus A times negative C, and that's going to be AB minus AC. So a few different ways you may see that, but the same underlying property. Let's talk about first the groupings you may see. So the way that I showed it was A times B plus C, but you may see groupings different than this. Maybe it looks like B plus C. Maybe it's square brackets, or something like that. You may see different types of grouping, but anything that would be considered parentheses or brackets in PEMDAS or BEMDAS, that first letter there, the P or the B, depending on how you learned it, is going to be considered grouping. So let's look at a few examples. Let's look at, let's say 4 times x minus 8 minus x plus 3. Let's do plus x plus 3 first. So the first thing we're going to do here in the order of operations, let me just put that back up here, parentheses. So let's look inside the parentheses. Is there anything we can simplify here? The answer is no. So we don't have any parentheses. Exponents, no exponents in this. Next is multiplication, and we do have multiplication. So multiplication is right here. So let's go ahead and do that. The distributive property says that 4 times x minus 8 is 4 times x minus 4 times 8. And we still have x plus 3. So let's go ahead and simplify what we have here. We have 4x minus 32 plus x plus 3. But we know by the associative property, we don't actually need those parentheses there. So let me go ahead and get rid of those. So now we can combine like terms. We have our x terms here. That's 5x. And we have negative 32 and positive 3. That's going to come out to be negative 29. And so we can simplify now using the distributive property. Okay, let's look at maybe another one that's a little more involved, which is going to be 4 times x minus 8 minus x plus 3. Well, we've already done the, again, there's nothing to do here with parentheses or exponents, so we're on to multiplication. But really we have two multiplications here. And let me write that out here. We have 4 times x minus 8. And really what we have here, and I'll write this in green, is plus negative 1 times x plus 3. So we have two different multiplications here. So let's go ahead and do those. I'm going to drop the equal sign over here. 4 times x minus 8, we have 4 times x, and we have 4 times 8. If you remember from the previous page, I'm going to use this property here to say that that is just that. And then we have plus, and we have negative 1 times x, and negative 1 times 3, right? Because we distributed the 4 to the x and to the negative 8, and we're distributing the negative 1 to the x and the 3. So now let's do some simplification. 4x is simplified. 4 times 8 is 32. Negative 1 times x is just negative x. And negative 1 times 3 is negative 3. So we have 4x and negative x, that's 3x. And we have negative 32 and negative 3, that's negative 35. So that's how we simplify using the distributive property. Let's look at maybe another one. We have evaluate 2 times 8z plus 5, where z is equal to 2. But let's do this using the well, we could do it two different ways. And in fact, let me just draw a line here in the middle. We'll start with plugging in first. So we have 2 times 8 times 2 plus 5. That's 2 times 16 plus 5. That's 2 times 21, which is 42. But now let's, let me actually move this line over because I think we'll need a little more room. So our answer is 42. We know that just from plugging in, but let's use the distributive property first. So we have 2 times 8z plus 5. That's going to be 2 times 8z plus 2 times 5. So 2 times 8z plus 2 times 5. 2 times 8z is 16z. 2 times 5 is 10. Now let's plug in. Z is 2. So 16 times 2 plus 10. 16 times 2 is 32 plus 10. That's going to give us 42. So just additional verification that this distributive property does actually hold, and it obeys the properties that we think that it does, and that we would expect. Let's do another one that may be a little unexpected. We're going to want to simplify 37 minus 2 times the absolute value of 4 minus 7 times 3 minus 5. Oops, 3 didn't show up. Okay, it's going to be important to remember our PEMDAS rules here. Again, we can do this a few different ways. We could first do the distributive property, or we could plug it, or we could simplify in general. But let's just do this how we would, the kind of the easy way, or what I would consider the easier of the methods, and that is just simplifying straight across. So first we look for parentheses. We have two sets of what we would consider parentheses or bracket like objects, and I'll underline those. Here's set number 1, and then here's set number 2. Note that set number 1 is inside of set number 2, so we're going to do it first. We do the innermost parentheses first. So 37 minus 2 times the absolute value of 4 minus 7. 3 minus 5, negative 2. And we still have parentheses out there, but we don't have, we need to simplify this first, this inner bit. And in order to do that, we're going to have to do the multiplication right here, right? Because the multiplication will come before the addition and subtraction. So 37 minus 2 times the absolute value of 4 minus 7 times negative 2 is going to be negative 14. But we can rewrite that as 4 plus 14, right? Because we have minus a negative, that's the same thing as a positive. 4 plus 14 is 18. Now, the absolute value of 18 is just 18, so we have 37 minus 2 times 18. 37 minus 36, we get 1. Okay, now keeping that in mind, let's go to the next page and do this again using the distributive property. 37 minus 2 times the absolute value of 4 minus 7, 3 minus 5. Okay, let's remind ourselves of the Again, 2 sets of parentheses. We have to do the first, we have to do that, and then of that we have these parentheses here. But instead of simplifying the parentheses the way we did it before, let's use the distributive property to simplify. So we have 37 minus 2 times the absolute value of 4 minus, and really this is plus. Let's go ahead and make that this extra step so we can actually see what we're multiplying. It's not 7 times everything, it's going to be negative 7 times everything. So we get 37 minus 2 times the absolute value of 4 plus negative 7 times 3 plus negative 7 times negative 5. 37 minus 2 times the absolute value of 4. That's going to be minus 21. And then we're going to have plus 35 because multiplying 2 negatives give you a positive. Now we can, inside absolute values, we may have talked about this in an earlier lecture, I can't recall. But if not, let's go ahead and talk about it here. A times the absolute value of well, B plus C. Maybe this is the right lecture to talk about it. Let's actually do this. A times the absolute value of B is equal to, if A is positive, let me back up here. The absolute value of A times the absolute value of B. That's going to be the absolute value of A times B. You can lump them together first. So that's because we don't care about signs. Now, this works. We can say A times the absolute value of B is equal to the absolute value of A times B if A is positive. So that is if A is, well, greater than or equal to 0. It could be 0. So using this property right here, oh, one more thing. Otherwise, A times absolute value of B is negative A times B. That is if A is less than or equal to 0. So this is actually the property we're going to use. So what we have here is 37 plus negative 2 times the absolute value of 4 minus 21 plus 35. And instead of simplifying this like we typically would, let's use the distributive property just to make the point here. That's going to be 37. And remember, we're going to end up doing minus the absolute value here of negative 2 times 4 plus negative 2 times negative 21 plus negative 2 times 35, running out of room. There we go. So we get 37 minus negative 2 times 4 is 8. Negative 8, sorry. Negative 2 times negative 21 is going to be, what is that, 42? And then negative 2 times 35 is negative 70. So then we get 37 minus. Okay, we got negative 78. I'm going to use those. Negative 78 plus 42 is going to be negative 36. Okay, now we can simplify this further. We get the absolute value of negative 36. Well, remember, here's 0. Here's 36. Here's negative 36. Negative 36 is 36 units in the left direction. So, and for absolute values, all we care about is the magnitude. So the absolute value of negative 36 is, in fact, 36. So this evaluates the 36, but we're going to keep the negative there. 37 minus 36 is 1. So same answer as what we got before, just using the distributive property. And in fact, a lot of these multiplications, a lot of these multiplications we actually did implicitly over before. So this is using the distributive property with real numbers. There's one more case that we need to talk about, and that is, again, we talked about A times B plus C. We talked about B plus C times A. And now we need to talk about A times B times C. We can actually use the associative property here of multiplication and say that this is the same thing as A times B times C, which means we don't really need the, it doesn't matter which order which order we do the multiplication in. So we don't actually need the parentheses at all. So this is A times B times C. So there's that one. This one is AB plus AC. This one's still AB plus AC. And I guess we need to talk about the A times B minus C is AB minus AC. And then B minus C times A is AB minus AC. And then this one in the middle here, which is that for multiplications, it doesn't matter which way we group. And so we can write this unambiguously. Okay, that's going to be everything for the distributive property. I'll see you all